Alright, so in this video we're going to be looking at angles in a semicircle, and essentially what I mean by angles in semicircle, it's when I draw a triangle and one of my lengths is the entirety of the diameter, and then two other lengths come off it to form that triangle. So here in the second one, because that length there is my diameter and then I've created that triangle, essentially I've got the same idea of a triangle in a semicircle. And the key thing that happens is that the angle that is opposite my diameter, so that's going to be this angle here, and in this case that angle there, they are always going to be at 90 degrees. So they're always at a right angle. So again, when I have my diameter line, the angle opposite it is always 90 degrees. So let's take a look at how we can use this in some questions. So the first one, and for all of these I'm being asked to fill in the missing angles. So I've got that 53 degrees and I go right down here at the bottom, that's my diameter. Opposite that is going to be my right angle, so I'll draw my right angle. And then I've got to figure out what this last remaining angle here is. So I'm going to do 180 and I'm going to take away my other two angles. So that's going to be 180 take away 143. And so that's just going to equal 37 degrees. Okay. So then the next one. So this time I've been given that angle on the outside. But remember, angles on a straight line must add up to 180. So I've got that 130 on the outside, and 180, take away the 130, that's going to give me 50 degrees. Then I've got my diameter line here, so that means the angle opposite it, that's going to be 90 degrees. And then my last angle here, take away my other two angles added together. Oops, sorry, got a bit squished there. So 180, take away 140, and that's just going to give me 40 degrees. All right, two more examples. So this time, this is actually going to combine our previous video knowledge. So key thing here is that I've got my center point marked, and I've got my radius line coming off, which means I've got an isosceles triangle here. And then I've got another isosceles triangle here. So that's making my two isosceles triangles. So to start off with, that 35 degrees, that's also going to be 35 degrees down here. And then adding them up, that's 70. Take that away from 180. That's going to give me 110 degrees here. Now I can go about this in different ways. I could just focus on the fact that I've got this angle on a straight line there, and I could use that knowledge to find out the angle on this other side. But what I'm actually going to do is I'm going to use the fact that I know that this bit here is going to be at 90 degrees because it's opposite my diameter line. So because that's at 90 degrees, that means this other angle here is going to be 90, take away 35 degrees, and so that is just going to be 55 degrees. So that means this angle here is also 55 degrees, and then when I find my last angle, add them up, gives me 110, 180, take away 110, that's going to give me 70 degrees in there. And then same idea for our last one then. So I've got that 50 degrees. I've got my isosceles triangles again because those lines there make up my radius. So that means this angle and this angle are the same. So 180 take away 50 gives me 130. Divide that by 2, that's going to give me 65. And 65. And I'm just going to use my knowledge on my right angle. So that's going to be a right angle up there in the top corner. And so 90 degrees, take away 65. That would give me 25 degrees there. So down here is also 25 degrees. And then my last angle, I can use my straight line knowledge here, 50 degrees. And then take that away from 180. That's going to give me 130 degrees in there. So that's essentially the main idea. The key thing is just look out for that diameter line, and that means whatever angle is opposite it is always a right angle. Let me know if you have any issues, and good luck with the work.